Hello and welcome to Mathematics Made Easier channel. This is your favorite mathematics user, Comfort Amwakun Atta. I welcome you all to this channel, and those joining me for the first time, I give you a special welcome. If you are yet to subscribe, please look down there and click on the subscribe button to subscribe. Then you click on the notification bell to receive updates all the time. Good. In our previous lesson, we started with trigonometry, and I promised to continue with you. So relax, pick your jolters, and go through today's class with me. So for today, our concentration is going to be on angles of elevation and depression. And I have some question here. But before I come to the question, let's see something over here. Now, when you talk about angle of elevation, let's assume we have the horizontal line. This is our horizontal line. And this is Amma. Now, Amma is standing over here and look up, or raise the eye level up. So Amma, in other words, Amma elevates her eyes up, and so an angle will be formed over here. She's standing here at the base and elevating her eye level up. It means an angle will be formed here, and this angle is called grade, the angle of elevation. Angle of elevation. Good. Again, now let's make it gender balance. When Kofi is at the top and Kofi looks down, so this is Kofi, and he looks down. Okay, that he brings his eye level down, an angle will be formed. And so this angle forming over here is called angle of depression. Angle of depression. Good. All right. So this is our horizontal line. So knowing this, let's now go back to our first example. A pole and a stick stand vertically on a level ground. We are going to solve this step by step. A pole and a stick stand vertically on a level ground. So let's do that. Okay, so this is the pole and this is the stick. And they are all standing on a level, pardon me for my diagram, okay? Okay, let's do something to represent something good. So this is the pole and this is our stick. Good. Let's clear it. Okay. Then they are standing on a level ground. This is the level ground. And so we get our right angle triangles over here. Okay, now let's go back to our question and still continue with our diagram. A pole and a stick stand vertically, and they are all standing straight on a level ground. The stick is 25 centimeters long. So let's go back. This is the stick. Stick and pole. They are saying the stick stands 25 centimeters long. It means the measurement over here should be 25 centimeters, this side. That's the length of the stick, 25 centimeters long. Then what again? Then they are saying that and cast a shadow of length 20 centimeters. And cast a shadow of length 20 centimeters. You know, shadows are not formed upwards. Shadows are formed at the base. So we have the shadow forming over here, 20 centimeters long. Okay. So this is the shadow of the stick. And it is forming over here. This is our stick. And this stick is casting a shadow of 20 centimeters. What do we have again? If the pole also casts a shadow of length 5 meters, so now let's go to the pole also. This is the pole, and this is the length of the pole, the shadow. And it's saying that if it also casts a shadow of 5 meters long, so this is the shadow casting by the pole. What are they now asking us to do? What is the length of the pole? So from our diagram, they are asking us to find the height of the pole. So this is the height of our pole. The height of our pole. So let's erase this. Okay. Okay, good. So the height is what we are looking for. What is the height of the pole? Excellent. So you can label this as the pole. You already know it. Now this is our diagram. How do we find the height of the pole? So where is the angle forming? It is forming over here. Someone stands there. Someone stands here and elevates the eyes to the sun. Okay. So labeling our diagram, we can have A, B, and C. Good. So now how do we find the angle over here? I told you earlier on that if you have two sides, you can find an angle. And from this right angle triangle, we have two sides given. That is, we have the opposite over here and the adjacent over here. So we are going to use great tan. So we are going to have tan theta is equal to opposite over adjacent. If you don't want any trouble, go the class one way. And so this is giving us tan theta is equal to opposite here is 25 over adjacent is what, 20. And so we are getting tan theta is equal to, simplifying this, we are going to get 1.25 centimeters. Okay, that is tan theta. Let's make this equation 1 because we have another right angle triangle here. Then we pick the bigger triangle. The bigger triangle. So let's pick that one, 2, and see. So for the bigger triangle, we have the diagram like this. We have the height, which is unknown, and that is what we have to look for. And we have this whole length over here as 5 meters. Okay, as 5 meters. So 5 meters. Then we have the angle over here. Now ask yourself, can you work with different units? No. Obviously, you have to change one to the other. This is meters, and this is what, centimeters, or these are centimeters in centimeters. So we have to convert the meters to centimeters, and that will give us, so we have 5 meters is equal to 500 centimeters. So we have this side now to be 500 centimeters. Now you ask yourself again, which of the 3 ratios can you use to solve this? We have opposite, but angle is directly opposite to the height. Then adjacent to this side, 5 meters. So you are still going to use your SWA, the tan over there. So you are going to have tan theta is equal to our height over the 500 centimeters. We are looking for height. So therefore, H is equal to 500 tan theta. Okay. So what do we do over here? Don't forget that, and this is our equation 2. So from equation 1, what did we get for equation 1? We had tan theta is equal to 1 point. So from equation 1, we had tan theta is equals 1.25 centimeters. So what do you think we can do to get our h? We simply substitute this value into equation 2. So substitute equation 1 into equation 2, and that will give you a final answer. We are getting h is equal to 500 times, wherever you see tan theta, put 1.25 over there. And so multiply this for me and tell me the answer. Okay, so after punching, I had 625 centimeters. 625 centimeters. Now let's convert this unit to meters, and this will give us 6.25 meters. So therefore, we are getting our height. So height of the pole is equal to 6.25 meters. So simple, isn't it? Great. Now let's pick our second example. And I'm expecting you solve this even before I solve it. So let's continue. So we have our second example, and it goes like this. A vertical pole is 6 meters high. It casts a shadow of 9 meters long. At the same time, a tree casts a shadow of 30 meters long. Find the height of the tree. So with this, we are going to draw our tree first. So the tree is longer than the pole. So this is our tree. Then we have our pole over here too. Then they are saying that, pardon me for my diagram, the software that I'm using, so sometimes we don't get it very straight as we want. Okay, so we are enclosing to get our right angle triangles. Perfect. Okay, so we have our tree and our pole. So now what do we do? A vertical pole, so it means the height of the pole is what? 6 meters. So you have the height here to be 6 meters. Then it casts a shadow of 9 meters long. So where do you think we'll have our shadow? This is where the shadow of the pole will be formed. Okay, the shadow of the pole. Good. Then the tree also casts a shadow of 30 meters long. Now we have the shadow of the tree. We have the shadow of the tree also casted over here as 30 meters long. Okay, 30 meters long. This is 30 meters. Okay. Now find the height of the pole. How do you find the height of the pole? Someone is standing here and that person observes or raise the eye level up. So this is the angle of elevation forming over here. So how do you find the height of the pole? As we did for the first example, that is how we are going to solve for this as well. So picking this right angle triangle out, we are going to get opposite. This angle theta is directly opposite to this side and adjacent to this side. So we are going to get, so let's say A, B, and C. Okay, so we are going to get tan theta is equal to tan theta is equal to line, okay, DE is equal to line DE over the adjacent, that is line AE, line AE. Good. So let's just substitute them into it. We are going to get tan theta, which is unknown. It's equal to the line DE is what? 6 meters over line AE is what? 9 meters. So what are you going to get for the tan theta? Simplifying this, we are going to get, okay, so let's maintain it 6 over 9. And let's make this one as equation 1. Then we pick the second one, this bigger one. Okay, that is a tree. So picking the tree 2 out, taking the tree out, we are going to have, what was the height of the tree? We don't know. So let's say the height is h. Then we have, that is CB, okay? CB. Then we have, so A, B, C. A, B, and C, okay? Then we have the theta and the adjacent as 30. We have BA as 30 meters. And the, what again was given here? Okay, so that is that, and our angle inside of it. Okay. So which of the three ratios can we apply to find the height of the tree? We can apply the tan because this angle theta is directly opposite to this side and adjacent to this side. Okay, so we are going to have tan, that is 2. Tan theta is equal to line BC over line BA. Okay, so we are getting tan theta is equal to, what is BC? Unknown. That is what we have to look for. And BA is what? 30. So line BC is equal to 30 times tan theta. Do we know tan theta? Good, yes. So from equation 1, so this is our equation 2, okay? So from equation 1, tan theta was given as what? Let's go back, 6 over 9, okay? 6 over 9. So substitute equation 1 into equation 2. And that will give us line BC is equal to 30 times 6 out of 9. And that will give us what? 20 meters by simple simplification. All right, so that is for question 1 and question 2. And I believe when you make this question anywhere or sample questions like this, you will be able to solve it, right? Good. Now pick an assignment. So try this. Try this. So this is our assignment. The shadow of a vertical pole is 50 centimeters long. If the height of the pole is 2 meters, correct the nearest degree, the angle of elevation. Don't forget to change the unit to be of the same unit. Thank you so much for your time. I believe this tutorial was helpful. Please do not forget to share the links to your friends to also try them out. Okay, so keep watching this channel as I bring you more tutorials. Thank you and stay safe. Bye.